Hey guys, welcome back to my channel. Today we're going to do Excel International Advanced Level Maths Paper 3, which is for Pure Maths 3. This is for May 2024. I've already uploaded the videos for Paper 1 and Paper 2, which you can access at the link above. Let's start with this one and see what kind of questions came in this paper and were they easy or difficult overall. So the first question is about absolute functions. It says figure 1 shows a sketch of the graph with the equation y equals to f of x. F x equals to 2 times modulus of x minus 5 plus 10. The point P shown in figure 1 is the vertex of the graph. State the coordinates of P. So to find the coordinates of P, we can see that it's the vertex. So to find the vertex, we're going to use the absolute function, and the format is the same as that of a quadratic equation. You remember in a quadratic equation, it was y equals to a times x minus h whole square plus k, where h and k were the coordinates of the vertex. So over here, h is 5 and k is 10. So that's your coordinate of P. 5, 10. Then it says, use algebra to solve the inequality 2 modulus of x minus 5 plus 10 greater than 6x. So in this case, what we're going to do is, first we're going to isolate the modulus of x minus 5 on one side. So let's write this like this. And modulus of x minus 5 is greater than 6x minus 10 over 2. So that's going to give us 3x minus 5. Now we're going to split this into two inequalities. One inequality is going to be the same, but without the modulus sign, obviously. That's x minus 5 greater than 3x minus 5. The other one is going to be x minus 5, which is less than minus bracket 3x minus 5. Because if you remember, when we remove the modulus sign, we get a positive and a negative value. So that's why we're splitting this into two inequalities. So if we solve the first inequality, it's x minus 3x greater than negative 5 plus 5. Negative 2x is greater than 0. X is going to be less than 0. And over here, x minus 5 is less than negative 3x plus 5. So x plus 3x over here less than 5 plus 5. For x is less than 10, and that means x is going to be less than 10 over 4, which we can simplify to 5 over 2. Now we have two values, x equals to 0 and x equals to 5 over 2. So to figure out which one is the solution, we're going to put them back into the initial equation and see if it works. So if I use the first one, which is x equals to 0, I'm just going to write this as an equation, not an inequality. So 2 modulus of 0 minus 5 plus 10 is equal to 6 times 0. So that's 2 modulus of negative 5 plus 10 equals to 0. Modulus of a negative number is positive, so that's 2 times 5 plus 10 equals to 0, which is 10 plus 10. And we can clearly see that 20 is not equal to 0, which means this is not a solution. If both sides were equal, then it would be a solution. Now, at x equals to 5 over 2, it's going to be 2 modulus 5 over 2 minus 5 plus 10 equals to 6 times 5 over 2. So that's going to be 2 modulus of negative 5 over 2 plus 10 equals to 15, which is 2 times positive 5 over 2. That's going to give us 5 plus 10 equals to 15. That's 15 equals to 15. Both sides are equal, which means it is a solution. So your answer is going to be x is less than 5/2. That's your final answer for part B. Then it says, find the point to which P is mapped when the graph with the equation y equals to f of x is transformed to the graph with the equation y equals to 3 times f of x minus 2. So transformations are an extension of what you've already learned in your IGCSE. So we have y equals to f of x, which has the point 5 and 10, which is mapped to y equals to 3 times f of x minus 2. So as you can see, it's x minus 2, which means we move the graph horizontally 2 units to the right. And so it's 3 times f of x minus 2, which means the y value is stretching by a scale factor of 3. So to x, we're going to add 2, and to y, we're going to times it by 3. So that's 7 and 30. So the coordinates are 7 and 30. That is your answer. Then it says, we have function g of x equals to 2x squared minus 5x plus 8 over x minus 2. Where g of x is in, where we have to write g of x in the form of ax plus b plus c over x minus 2, where a, b, and c are integers to be found. So for this, we're going to convert this into partial fractions. So 2x squared minus 5x plus 8 is divided by x minus 2, which is equal to ax plus b plus c over x minus 2. When we cross multiply x minus 2 from the left-hand side to the right-hand side, it's going to be 2x squared minus 5x plus 8 equals to ax times x minus 2 plus b times x minus 2 and plus c. This is the first step. You always cross multiply the denominator of the left-hand side towards the right-hand side, and then we get rid of the fraction like this. After this, what you're going to do is going to expand the brackets, and then you're going to put like terms equal to each other. For example, if there's an x squared, the quotient of x squared will be put equal to the quotient of x squared on the left-hand side and right-hand side. Same for the quotient of x and same for the constants. So let's expand the bracket now. That's going to be ax squared minus 2ax plus bx minus 2b plus c. So 2 equals to a minus 5 equals to minus 2a plus b, and 8 equals to negative 2b plus c. So 2 equals to a is the first answer. We put that in the second equation to find the value of b. That's minus 5 plus 4. That's going to be negative 1 equals to b. So I put this in the third equation. So 8 equals to minus 2 times negative 1 plus c. That's going to be 8 minus 2 equals to c, which is 6. So we have the values of a, b, and c. So it's going to be 2x minus 1 plus 6 over x minus 2. That is your answer. Then hence use algebraic integration to show that the integral of gx dx from 4 to 8 is equal to alpha plus beta times ln 3, where alpha and beta are integers to be found. So we're going to use the partial fraction for the integration. So it's the integral of gx from 4 to 8. That's the same as 2x minus 1 plus 6 over x minus 2 dx. So when you integrate this, we add 1 to the power of x, then divide by the new power. It's going to be 2x squared over 2. Negative 1 becomes negative x. And plus 6 over x minus 2 becomes plus 6 times ln x minus 2. And the limit is 4 to 8. So that's going to be x squared minus x plus 6 ln x minus 2 from 4 to 8. Put the maximum value first, so 8 squared minus 8 plus 6 ln 8 minus 2 minus 4 squared minus 4 plus 6 ln 4 minus 2. 64 minus 8 plus 6 ln 6 minus 16 plus 4 minus 6 ln 2. That's going to be 44 plus 6 ln 6 minus 6 ln 2. Combine the ln. So that's going to be 6 ln 6 over 2, which is going to be 6 ln 3. So 44 plus 6 ln 3 is your answer. Then it says the variables x and y are connected by the equation y equals to 10 to the power of 6 over x cubed where x is greater than 0. We have to sketch the graph of log of y to the base of 10 against log of x to the base of 10. Show on your sketch the coordinates of the points of intersection of the graph with the axis. Okay, so for this, let's first solve the equation over here. So we have y equals to 10 to the power of 6 over x cubed. So we're going to add logs. So it's going to be log of y to the base of 10. And when two terms are being divided, when you introduce logs, you subtract it. It's going to be log of 10 to the power of 6 with base 10 minus log of x cubed to the base 10. Next, we're going to bring the power down. So it's going to be 6 times log of 10 to the base 10 minus 3 times log of x to the base 10. So log of 10 to the base 10 equals to 1. So it's going to be 6 over here and 3 log of x to the base 10. So we can see that our gradient is 3 and our y-intercept is 6. So we can see that the gradient is negative 3 and y-intercept is 6. So we'll draw this rough sketch. Y-intercept is 6. Gradient is 3. X-intercept is going to be log of 10y equals to 6 minus 3 log of x 10. Since we're plotting log of y to the base of 10 against log of x to the base of 10, for the x-intercept we put log y to the base of 10 equal to 0 and find the value of log of x to the base of 10, which is going to be our x-intercept. And that is coming out to be 2. Because negative 6 divided by negative 3 is 2. So 2 is equal to log of x to the base of 10. So x-intercept is 2 over here. So we just draw a straight line, and that represents our equation right over here. Obviously, I'm drawing this freehand over here, so it looks a little rough, but you will draw this using a ruler. Then it says, figure 2 shows the linear relationship between log n to the base of 3 and t. Show that n equals to a times b to the power of t, where a and b are constants to be found. So now it's going to be the other way around. So we're going to begin with finding the gradient first. So m is going to be 4 minus 0 over 0 minus negative 2, which equals to 2. We already have the y-intercept, which is given in the graph as 4. So let's create the equation. Log of n to the base of 3 equals to 2 times t plus 4. So now I'm going to introduce logs on the right-hand side. So log of n to the base of 3 equals to 2t times log of 3 to the base of 3 plus 4 times log of 3 to the base of 3. Let's separate this. So now using logarithmic rules, I'm going to bring the 2t to the power of 3. So log of 3 to the power of 2t to the base of 3. And over here, the 4 goes up and becomes the power of 3. Now we combine the logs. Just going to be log of 3 to the power of 2t times 3 to the power of 4, and the base is 3. Now we can remove the logs on both sides, and n is going to be equal to 3 to the power 4, which is 81, times 3 squared is 9, so 9 to the power of t. This is what your equation is going to be, and that's exactly what the format was in the question. And it says that we have a function 8 sine x times cos x plus 4 cos square x minus 3. We have to write f of x in the form of a sine 2x plus b cos 2x plus c, where a, b, and c are integers to be found. So we have to rewrite this as a sine 2x plus b cos 2x plus c. For this, we'll be using the identities. So the initial equation is 8 sine x cos x plus 4 cos square x minus 3. We know that 2 sine x cos x equals to sine 2x. So if I split this into 4 times 2 sine x cos x, and we can rewrite the cos square x as cos 2x plus 1 over 2. Once again, I'm using one of the identities. Minus 3 comes as it is. So 2 sine x cos x gets replaced with sine 2x. And over here, when we simplify this, 4 divided by 2 is 2. So it's going to be 2 cos 2x plus 2 minus 3, which is going to be 4 sine 2x plus 2 cos 2x minus 1. That's your answer. Then it says that use the answer to part A to write f of x in the form of r sine of 2x plus alpha plus c, where r is greater than 0 and alpha is between 0 and pi by 2. Give the exact value of r and give the value of alpha in readings to 3 significant figures. So we're going to use another identity in this case. So we know the question wants it in the form of r sine of 2x plus alpha and then plus c. So whenever it's r times sine of angle being added to an angle or angle being subtracted from angle, we're going to use this rule. R sine of 2x plus alpha is equal to r sine of 2x times cos alpha plus r cos of 2x times sine alpha. If it was r times sine 2x minus alpha, then it would be r sine 2x times cos alpha minus r cos 2x times sine alpha. So it depends on like what the signs are. So over here, what we have is 4 sine of 2x plus 2 cos 2x. Just for this part, I'm not using the minus 1 right now. And that is equal to this, r sine 2x cos alpha plus r cos 2x sine alpha. Once again, I'm not using the plus c in the minus 1 part right now. So 4 sine 2x equals to r sine 2x cos alpha. So 4 sine 2x equals to r sine 2x cos of alpha. The sine 2x gets cancelled out. So 4 equals to r times cos alpha. Similarly, 2 cos 2x equals to r cos 2x times sine alpha, which means 2 is going to equal to r times sine alpha. We have these two equations which we're going to use in the next step. So to find the angle, tan alpha is going to be r sine alpha divided by r cos alpha. The r's get cancelled out. Sine is r sine alpha is 2 and r cos alpha is 4. So alpha equals to tan inverse of 204, which is basically 1 over 2. And that gives us 0.464 radians. Now for the value of r is basically square root of 4 square plus 2 square, which is going to be square root of 20, which you can rewrite as 2 root 5. That is r. So f of x is equal to 2 root 5 sine of 2x plus alpha, which is 0.464, and c is going to be minus 1. This is your answer in the format given in the question. Yeah, just like that. Then it says use the answer to part A to write f of x in the form of r sine bracket 2x plus alpha plus c. This is your answer to part B. Then it says hence or otherwise state the maximum value of f of x. So for the maximum value of f of x, we should remember that sine has a maximum value at positive 1. So what you will do is you will put sine equal to 1. So sine 2x plus 0.464 is 1 because at 1 they have a maximum value. So it's going to be 2 root 5 minus 1, and that's your maximum value of the function. Then it's asking us to find the second smallest positive value of x at which maximum value of f of x occurs, giving the answer to 3 significant figures. So second positive value at which the maximum value occurs. So for this, need to recall your sine graph. Sine graph is like this. Your first maximum value, which is 1, occurs at pi by 2. The second maximum value occurs over here after 2 pi. So 2 pi, this is 2 pi plus pi by 2, which is equal to 5 pi by 2. So at 5 pi by 2, we get the maximum value again, which means what we will do is we will put 2x plus alpha equals to 5 pi by 2. We know alpha has a value of 0.464. So 2x plus 0.464 equals to 5 pi by 2. 2x equals to 5 pi by 2 minus 0.464, which is equal to 7.389. We divide that by 2, and that equals to 3.69 radians. That is your answer. This is the function f and g are defined by f of x equals to 2 plus 5 ln x, where x is greater than 0, and g of x is 6x minus 2 over 2x plus 1, where x is greater than 1 over 3. We have to find f inverse of 22. So let's first find the inverse. So y equals to 2 plus 5 ln x. So let's make x the subject. So y minus 2 over 5 equals to ln x. To replace the ln, we add e on the other side. So e to the power of y minus 2 over 5 equals to x. So which means f inverse x is going to be e to the power of x minus 2 over 5. So f inverse of 22, that's going to be e to the power of 22 minus 2 over 5, which is going to be e to the power of 4. That is the value. Then it says use differentiation to prove that g is an increasing function. So if it's an increasing function, that means we have to differentiate it. So g of x is equal to 6x minus 2 over 2x plus 1. Since in this case, two expressions are being divided, we're going to use the quotient rule to differentiate it. Based on the quotient rule, the numerator becomes 6x minus 2, and the denominator is going to be 2x plus 1. We differentiate them separately first. U derivative is going to be 6. V derivative is going to be 2. Now, according to the quotient rule, it's u derivative times v minus v derivative times u divided by v squared. So we're going to put the values in this formula and then solve it. So we're going to put the values in this formula and solve it. So dy by dx is going to be 6 times 2x plus 1 minus 2 times 6x minus 2 divided by 2x plus 1 whole square. That's going to be 12x plus 6 minus 12x plus 4 over 2x plus 1 whole square, which equals to 10 over 2x plus 1 whole square. Now, if you notice, the numerator is positive, which is 10, and the denominator is getting squared. And we know whenever we square something, we always get a positive value, not a negative value. So this is an increasing function because the derivative is positive. It's not negative. So since dy by dx is greater than 0, it is an increasing function. That's your answer. Then it says find G inverse. So for G inverse, G of x is equal to 6x minus 2 over 2x plus 1. Cross multiply. Y times 2x plus 1 equals to 6x minus 2. 2xy plus y equals to 6x minus 2. Collect the terms with x on one side. So 2xy minus 6x equals to negative 2 minus 1. This is something that you've already learned in your IGCSE. This isn't something new. You rearrange it and make x the subject to find the inverse. Take x common, so bracket 2y minus 6 equals to negative 2 minus y. X equals to negative 2 minus y over 2y minus 6. So G inverse of x is going to be negative 2 minus 6 over 2x minus 6. Now we have to identify the domain for this. So for the domain, we will first find the restriction. So we know the denominator cannot equal to 0. So if we put 2x minus 6 equals to 0, what we get is x equals to 3. So x cannot equal to 3. Another restriction is going to be, if we go back to the question, we know that for g of x, x had to be greater than 1 over 3. So if we put it into the function, let's see what value we get. So g of 1 over 3 is equal to 6 times 1 over 3 minus 2 over 2 times 1 over 3 plus 1. That gives us a value of 0. If you remember from your IGCSE, if you have your original function and your inverse function, whatever is the domain and range of the inverse of the original, we swap it for the inverse. So the domain of the original becomes the range of the inverse, and range of the original becomes the domain of the inverse. So when x equals to 1 over 3, we're getting range as 0. 0 becomes your domain for the inverse, and over 3 becomes the range. And over here, we said that it has a restriction at 3. It cannot be equal to 3, which means it has to be less than 3, but greater than 0. So your domain is going to be domain for G inverse x is x is less than 3, but greater than 0. That is your answer. Then it says find the range of f of g. So for range of f of g, first we need to create our composite function. So you're putting g of x into f of x. So f of g of x is going to be 2 plus 5 ln, and x gets replaced with g of x, which is 6 minus 2 over 2x plus 1. Now we know, based on our working, that the inverse has a domain restriction at x equals to 3, which means if it's a domain restriction over here, it's going to be the range over here. So it's going to be 2 plus 5 times ln of 3. We're replacing the g of x function with 3 because that's the maximum value it can have for g of x. It cannot be more than that. So that's the restriction for g of x. It can't be more than 3. So when you put g of x as 3, the range for f of gx becomes 2 plus 5 ln 3. Once again, from the previous breaking, we found that the function g inverse of x had a domain restriction of 0 and 3. Like the domain had to be between 0 and 3, which means this is going to be the range restriction for the original function. So it cannot be more than 3. Hence, we put g of x as 3 in the f of gx equation. That gives us 2 plus 5 ln 3 as the range for the composite function. Then it says, in this equation, you must show all stages of the breaking. Solutions relying entirely on calculator technology are not acceptable. So figure 3 shows a sketch of part of the curve with equation y equals to root of y equals to root of 4x minus 7. The line L shown in figure 3 is the normal to the curve at the point P85. We used calculus to show that an equation of L is 5x plus 2y minus 50 equals to 0. So we know that the gradient of the curve is the same as the gradient of the tangent. But it's not the same as gradient of the normal. Why? Because the normal and tangent are at right angle to each other. They're perpendicular. So if we have the gradient of the curve, which means we have the gradient of the tangent, and if we have the gradient of the tangent, we can figure out the gradient of the normal by using the concept of perpendicular lines. That if two lines are perpendicular, the product of the gradients always equals to -1. Hence, keeping that in mind, we're going to differentiate the equation of the curve first, put x equals to 8 in it to find the gradient of the curve, and then further use that to find the gradient of the normal. So we have y equals to root of 4x minus 7. Let's differentiate this. So that's going to be 1 over 2 times 4 times 4x minus 7 to the power of 1 over 2 minus 1, which is 2 times 4x minus 7 to the power of -1 over 2. We'll put x equals to 8 in the equation. So that's going to be 2 times 4 times 8 minus 7 to the power of -1 over 2, which is going to give us a value of 2 times 25 to the power of -1 over 2. That's 2 over root of 25, which is 2 over 5. This is your gradient of the curve. So since the gradient of the curve and gradient of the tangent are the same, so we're going to do 2 over 5 times m2, which is gradient of the normal, equals to -1. So m2 is going to be -5 over 2. So since the line, the normal, also passes through point P, so we're going to use point P, which is 5, 8, which is 8, 5. And the gradient is going to be -5 over 2. So using point slope form, y minus 5 equals to -5 over 2 times x minus 8. You can also use slope intercept form. There's no restriction on the way you used to find the line of equation. So 2y minus 10 equals to -5x plus 40. 2y plus 5x minus 50 equals to 0. That is your equation. Then it's saying the region R shown here in figure 3 is bounded by the curve, the x-axis, and line L. Use algebraic integration to find the exact area of R. So if you look at it, this is the region that's bounded by the curve, this part, and then we have this triangle over here. So we know this point is 8, 5. So the height of the triangle is 8. The x coordinate is 5 over here. We need to find this x value. I need to find this x value. Without these two x values, we cannot integrate it. So to find those x values, in the curve equation, we'll put y equals to 0, and in the line equation, we'll put y equals to 0 as well to find the x-intercepts for both the curve and the line. So for the first one, 0 equals to root of 4x minus 7. That 0 equals to 4x minus 7. 7 equals to 4x. 7 over 4 equals to x. That is the lower limit. Then 2y plus 5x minus 50 equals to 0. 2 times 0 plus 5x minus 50 equals to 0. 5x equals to 50. X equals to 10. So now for the upper limit, if you again go back over here, for integration, it's going to be from, so this is 8, not 5. This is going to be 7 over 4, and this is going to be 8, and this is 10. So this distance is 2, this is 5. So area of the triangle is going to be half times 2 times 5. And for the curved part, we will integrate the curve with the limit of 7 over 4 to 8. So area of triangle, let's find that first. So that's 1 over 2 times 2 times 5. That's 5 units squared. Now for the curve part, we're going to integrate the curve from the limit of 7 over 4 to 8. So that's root of 4x minus 7 from 7 over 4 to 8. Add 1 to the power, so 4x minus 7 whole power 1 over 2 plus 1 divided by the new power, which is going to be 3 over 2, and times it by the coefficient of x, which is 4. And the limit is again the same, 7 over 4 to 8. So 3 over 2 times 4 is 6. So 1 over 6, and it's going to be 4x minus 7 whole power 3 over 2. I just brought the 1 over 6 outside to make the calculation simpler. Want to keep it inside? That's also fun. So we substitute the maximum limit first. That's going to be 4 times 8 minus 7 whole power 3 over 2 minus 4 times 7 over 4 minus 7 whole power 3 over 2. Thirty-two minus 7 whole power 3 over 2 minus 0. That's going to be 1 over 6 times 125. So 125 over 6 is the area of the part that is under the curve. So total area which is basically R, is equal to 125 over 6 plus 5, and that is equal to 155 over 6. That is your final answer. So remember, if there's like a straight line intersecting the curve and you have to find the area under the, the graph, the curve, see if you can split the part and see if there's like another shape, if there's a rectangle, trapezium, triangle, whatever shape it makes. You have to find the area of that shape separately and then the part under the curve separately. If it's not underneath the curve, then you can't put a limit from 7 or 4 to 10. That will not give you the correct answer. So you have to be very careful about these things. Then it says, in this question, you must show all stages of working. Solutions relying entirely on calculator technology are not acceptable. So given that root 2 times sine of x plus 45 equals to cos of x minus 60. We have to show that tan x equals to negative 2 minus root 3. So we're going to use the identity once again. So root 2 bracket sine x times cos 45 plus sine 45 times cos x equals to cos x times cos 60 plus sine x times sine 60. So root 2 times sine x, cos 45 is 1 over root 2. And again, plus root 2 because we expand the bracket. Sine 45 is also 1 over root 2 times cos x equals to cos x times cos 60 is 1 over 2 plus sine x times sine 60, which is root 3 over 2. Further simplified, root 2 times 1 over root 2 is 1, so sine x. These root 2's also get cancelled out, so that's cos x. That's equals to cos x over 2 plus root 3 over 2 sine x. So now we collect the cos on one side and the sine on the other side. Sine x minus root 3 sine x over 2 equals to cos x over 2 minus cos x. That's 2 sine x minus root 3 sine x divided by 2 equals to cos x minus 2 cos x over 2. That's 2 sine x minus root 3 sine x equals to negative cos x. Take the sine x common. That's 2 minus root 3 in the bracket. Negative cos x over here. They want tan x equals to negative 2 minus root 3. Okay, so sine x over cos x is tan x. So let's bring that over here. And that's going to be negative 1 over 2 minus root 3. This is tan x. Now, since they want the rationalized version, so tan x equals to negative 1 over 2 minus root 3 times 2 plus root 3 over 2 plus root 3. That's going to be minus 2 minus root 3 over 2 square minus root 3 square, which is minus 2 minus root 3 over 4 minus 3, which is 1. So your tan x is equal to -2 minus root 3, which is also what's given in the question. Then it says, hence or otherwise solve for theta is from 0 to 180 for the same equation. For the equation root 2 times sine 2 theta equals to cos 2 theta minus 105. Now, in this case, what we're going to do is root 2 sine 2 theta equals to cos of 2 theta minus 105. So what we will do is we will put x plus 45 equals to 2 theta, because if we go back to the question, this is going to be the same as this. So let's put them equal to each other. So x plus 45 equals to 2 theta, which means x is going to be 2 theta minus 45. So which means it's going to be tan of 2 theta minus 45, because we said tan x equals to -2 minus root 3. Okay, so that equals to -2 minus root 3. And I'm going to find tan inverse of -2 minus root 3, which is going to give us a value of -75. Now tan is negative in the second quadrant and the third quadrant and the fourth quadrant. So one value is going to be 180 minus 75, which is 105, and then 360 minus 75, which is 285. So theta is going to be 105 plus 45 divided by 2, and 285 plus 45 divided by 2. So we get values of 75 degrees and 165 degrees. These are your solutions for the given equation. And since figure 4 is a graph showing the path of a ball after the ball has been hit until it first hits the ground. The vertical height, h meters of the ball, above the ground has been plotted against the horizontal distance traveled, x meters, measured from where the ball was hit. The ball travels a horizontal distance of d meters before it hits the ground. The ball is modeled as a particle traveling in a vertical plane above horizontal ground. The path of the ball is modeled by the equation h equals to 1.5x minus 0.5x times e to the power of 0.02x, where x is less than equal to d but greater than equal to 0. Use the model to answer part A, B, and C. Find the value of d, giving your answer to 2 decimal places. So since d is the horizontal distance that the ball travels before it hits the ground, so it's going to be, so the height is going to be 0, because h is the vertical height and we're talking about the horizontal. So for the first part, h is 0, x is d, which means it's going to be 1.5x minus 0.5 x times e to the power of 0.02x. 0 equals to 1.5d minus 0.5d times e to the power of 0.02d. So 0.5d times e to the power of 0.02d equals to 1.5 d. E to the power of 0.02d equals to 1.5d divided by 0.5d. So that is equal to 3. So 0.02d equals to ln 3. D equals to ln 3 divided by 0.02. And that gives a value of 54.93. Then part B says show that the maximum value of h occurs when x is 50 ln of 150 over x plus 50. So for that, we differentiate our h equation. So dh over dx is going to be 1.5 minus 0.5 times e to the power of 0.02x plus 0.5x times 0.02 times e to the power of 0.02x. Since 0.5x is being multiplied by e to the power of 0.02x, so we use the product rule for that part. So that's going to be 1.5 minus 0.5 times e to the power of 0.02x. 0.5 times 0.02 is going to be 0.01. So plus minus actually. So minus 0.01 x times e to the power of 0.02 x. And this is equal to 0 because it's talking about the maximum value. So 0.01 x times e to the power of 0.02 x plus 0.5 times e to the power of 0.02 x equals to 1.5. We can take e to the power of 0.02 x common. At 0.01 x plus 0.5 equals to 1.5. E to the power of 0.02 x equals to 1.5 divided by 0.01 x plus 0.5. Multiply everything by 100 on the right hand side to finish the decimals. That's going to be 150 over x plus 50. So now we just remove the e from the left hand side, bring the power down, so 0.02x is going to be ln of 150 over x plus 50. Then we divide this by 0.02, and 1 divided by 0.02 is basically equal to 50. So that is your value of x as given in the question. Then it says using the iteration formula x n plus 1 equals to 50, ln 150 over x n plus 50 over x1 is 30. We have to find the value of x2 to 2 decimal places, and then you have to find the value of x2 to 2 decimal places, and then find by repeated iteration the horizontal distance traveled by the golf ball before it reaches the maximum height, giving the answer correct to decimal places. So for this, x2 is going to be 50 ln 150 over x1, which is 30, plus 50. That's going to be 50 ln 150 over 80. That's going to be 31.43. And for second part, we're going to do repeated iteration till we get the same value. So for x3, it's going to be 50 ln of 150 over 50 plus 31.43, which gives the value of 30.54. Then we're going to repeat this again to find x4. That's going to be again 50 ln of 150 over 50 now plus 30.54, which gives a value of 31.09. Just like that, we're going to do repeated iterations. Next value is going to be 30.75. Then next is going to be 30.96. After that, it's going to be 30.83. Then after that, it's going to be 30.91. Then next, it's going to be 30.86. After that, 30.89. The 11th is going to be 30.87. 12th is going to be again 30.89. 13th is 30.88. 14th is 30.88, and so is the 15th, which means our value is 30.88. That is your answer. Because after repeated iterations, 30.88 is the only value that is being repeated 13th onwards. So that's your answer. Then says the curve shown in figure 5 is equation x equals to 4 sine square y minus 1, revised from 0 to pi by 2. The point P, which is k pi by 3, lies on the curve. Verify that k equals to 2. So for that, we just put the value of x equals to k and y equals to pi by 3 in the equation. And that should give us the value of k as 2. So simple as that. X equals to 4 sine square y minus 1. K equals to 4 sine square pi by 3 minus 1. If you put that in the calculator, that gives us k equals to 2. It says find dx by dy in terms of y. So we differentiate the equation now. Dx by dy. So that's going to be power down, so 2 times 4 sine of y times the derivative of sine, which is cos. That's going to be 8 sine y cos y. First you differentiate the power, then you differentiate the trigonometric function. So that's dx by dy in terms of y. Then it's saying, hence show that dy by dx equals to 1 over 2 root of x plus 1 times root of 3 minus x. So we know that x equals to 4 sine square y minus 1. So if we make sine square y the subject, it's going to be x plus 1 over 4 square root both sides. So that's going to be root of x plus 1 over 2 equals to sine y. And similarly, we know that cos square y is 1 minus sine square y. That's going to be 1 minus, that's going to be x plus 1 over 4, because sine square y is x plus 1 over 4. That's going to be 4 minus x minus 1 over 4, just cos square y. That simplifies to 3 minus x over 4. Now we square root it. So cos y is root of 3 minus x divided by 2. Now we're going to plug this in the equation, the dx by dy one. So dx by dy equals to 8 times sine y. Sine y is root of x plus 1 over 2 times cos y is root of 3 minus x over 2. So that's going to be 2 times root of x plus 1 times root of 3 minus x. It's for dx by dy. They want dy by dx, so we're going to flip it. So to find dy by dx, we're going to flip it. So dy by dx is going to be 1 over 2 root of x plus 1 times root of 3 minus x. That is your answer. After that, they're saying that the normal to the curve at P cuts the x-axis at the point N. Find the exact area of triangle OPN, where O is the origin. Give your answer in the form A pi plus B pi. Give your answer in the form of A pi plus B pi square, where A and B are constants. So, normal to the curve at P. So, let's say this is, that's it, this is N, and then triangle OPN. So, this is triangle OPN. So what we can do is, using the gradient of the curve, we can find the gradient of the normal, create an equation to find the value of n, and then use that to figure out the area. Okay, so let's start with find the gradient of the curve first. So dy by dx is this. So you find the gradient of the curve at point P. So dy by dx at P, which is 2 and pi by 3. So dy by dx is going to be 1 over 2 times root of 2 plus 1 root of 3 minus 2. That's going to be 2 times root 3 times root 1, which is the same thing. So 1 over 2 root 3. So gradient of normal is going to be negative 2 root 3. Now we create the equation. The normal is also passing through point P, so we use the coordinates of P and this gradient, negative 2 root 3. So y minus pi by 3, so negative 2 root 3 times x minus 2. That's 3y minus pi equals to negative 6 root 3 times x minus 2. Which is going to be 3y minus pi equals to negative 6 root 3x plus 12 root 3. We need to find the coordinates of n where y is 0. So y equals to 0. 3 times 0 minus pi equals to negative 6 root 3 x plus 12 root 3. So 6 root 3 x equals to pi plus 12 root 3. X is going to be pi plus 12 root 3 over 6 root 3. So we have the coordinates of n, which is this 0, and O is 0, 0. P is k pi by 3. So this is our base, which is what we just found, and this is our height, which is pi by 3. So we just use this to find the area. So area is going to be 1 over 2 times pi by 3 times pi plus 12 root 3 over 6 root 3. So that's going to simplify to pi square over root. That's going to give us pi square over 36 root 3 and then plus pi by 3. That's your answer. And with that, we're done with the paper. If you have any questions or confusions about anything, please leave a comment below and I'll help you out. And if you understood everything, please like and subscribe, share this video with your friends. And don't forget to check out the other videos in this playlist, because in this playlist, you will come across other papers for A-level maths as well.